Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been delivering sessions on software engineering. In this particular session, I will be continuing on the project quality management. So, this objectives is very common with what we have described in the previous session. So, we will be talking more on the quality perspective of all the information technology related projects. We will be explaining on the various quality standards that quality experts have defined, and we will try to enforce these quality on to the processes of the IT projects. So, this is one of the quality experts Ishikawas diagram on quality. This is a simple fishbone diagram wherein at various levels of perspective, say from the beginning of system, software, hardware and services that system needs to process, what are the various problems that each and every phase has come out with. Say for example, in the training phase, during the training phase, every user might be able to give an user ID and password. So, user did not reset the password which has been given in the beginning. So, what are the problems that he might encounter if he has not reset the password? So, user did not check box to save password, user keeps forgetting the password again and again. So, in those situations, how are we to ensure the quality of the same product, or are we giving them an instruction that this quality has to be enforced during the training phase. So, likewise for various processes under this project development or product development, we will look at the quality at different levels. So, in terms of software, in terms of users hardware, in terms of system hardware, what are the problems the user cannot get into the system. There is another quality award which has been given in the US, which is defined after the Secretary of Commerce, who is Malcolm Baldrige Award and ISO 9000 award. This award is to be given for different services starting from service sector, IT enabled sectors and so. This Malcolm Baldrige Quality Award was started in the year 1987 to recognize companies with world class quality. If you look at the history behind this Malcolm Baldrige Award, almost around 116 awards so far has been distributed right from its inception, of which 106 awards have been uniquely identified awards, and the remaining awards, 108 awards have been uniquely identified innovative awards, quality accomplished awards. The remaining 8 awards have been repeated awards for the same company for ensuring or for confirming on the qualities. So, ISO 9000 provides minimum requirements for an organization to meet their quality certification standards. We have talked about quality planning in the previous session also. Now also we will talk about how to plan for ensuring high quality systems. So, it is important to design the quality and communicate important factors that directly contribute to meeting the customer requirements. So, we may have to design experiments which helps identify which variable have the most influence on the overall outcome of the process. So, we have to look at what are all the different processes wherein the outcome is given highest importance, or we may have to design appropriate experiments to focus on the outcome of the project. So, many scope aspects of the IT projects affect quality, like functionalities provided by the system, features of the system, system output, performance, reliability and maintainability. So, these are quite some of the characteristics, or these are some of the quality standards that we may have to define, or we may have to be very much in conformance to define our quality. So, after your planning of quality, we may have to ensure or assure on the quality. So, quality assurance includes all the activities related to satisfying the relevant quality standards for the project. So, another goal of quality assurance is the continuous quality improvement. So, initial stage at version 1, so what are the quality standards that we may have met, or the processes that we may have met, and assurance 1.1 we may have another level of quality which we may have to meet. So, by where after having different iterations of these quality or several improvements of the quality, we may have to benchmark the quality standards. So benchmarking can be used to generate ideas for quality improvements. And there are different levels of audits, quality audits, which help to identify lessons learnt that can improve performance on current or future projects. So after having planned thoroughly on the quality, ensuring or assuring on the quality, we may have to maintain or control the quality. So the main outputs of quality control are acceptance decision, rework, and process adjustment. We may have some of the tools and techniques for quality control like Pareto analysis. This is a very common principle, Pareto's principle, that is being used very commonly, which says 80-20 rule. 80% of the effects is because of 20% of the costs. Say this was defined by an Italian where he said 80% of the land is being owned by 20% of the residents. So 20% of the people owns 80% of the lands in Italy. So likewise, this principle has been made very common. 80% of the effects is being caused by only 20% of the costs. So there are another quality tools which is called statistical sampling. There are tools and techniques like quality controls charts and testing. To look at in detail on the Pareto analysis involves identifying the vital few contributors that account for the most quality problems in a system. Only very few contributors who talk majorly on the quality, but the impact of those quality people into the system is being vital. So this is also called, as I have already said, this is also called 80-20 rule, where 80% of the problems are often due to 20% of the causes. 80% of the effects are often due to 20% of the causes. Pareto's diagram are histograms that help identify and prioritize problem areas. This is a sample Pareto's chart where we will try to identify the number of defects or number of complaints that the customer has posted per week, what are the stages at which we have taken, or what are the continuous improvement phases which we have taken to assure 100% quality centric work. So with regard to login problems, most of them have a problem in the beginning, then system lockups, system is too slow, system is too hard to use, so it means user interface is not that cumbersome and reports are inaccurate. So as and when possible, we are trying to ensure that the quality of the product is being increasing. So we cumulatively make it 100% defect free, we make it the effect of the complaints that we have received from the customer is being reduced. There are other tools and techniques like statistical sampling and standard deviation. Statistical sampling involves choosing part of population of interest for inspection. The size of a sample depends on how representative you want the sample to be. So we can actually define on the sample size. So sample size is 0.25 into certainty factor by acceptable error square. So this is a very common statistical tool that we have been using. Commonly used certainty factors are desired certainty and certainty factor. So there is a 95% certainty that the sample size, if there is a 95% certainty, then the sample size would be 384. When there is 90% certainty, then the sample size will be 68. When there is 80% certainty, then the sample size would be 10. So if you take a very minimal sample size and the application of the sample size is being too hard, maybe this small sample size would also need to bring in a lot of accuracy on the product that we tend to develop. As a continuation of that, we may have to estimate the standard deviation to identify how much it deviates from the routine of work that we have been performing. So standard deviation measures how much variation exists in the distribution of data. So throughout, when we look at the entire distribution of data, if the mean is at the center, then how much it is being deviated we can easily identify. So a small standard deviation means that the data cluster closely around the middle of distribution and there is a little variability among the data. That is what I have been mentioning. So a normal distribution is a bell shaped curve that is symmetrical about the mean and average value of population. So I'll show the representation of a sample normal distribution curve. This is a bell shaped curve where the mean is identified to be at the middle, and the difference between this value, that is between 1 sigma, minus 1 sigma and plus 1 sigma is 68.3, and the difference between minus 2 sigma and plus 2 sigma is 95.5, and the difference between minus 3 sigma and plus 3 sigma is 99.7. So when we do a certain sampling of a product, that means when we accomplish a task which is 99.7%, we are into the defect, we are easily getting into the defect without having maintained quality. But then when we ensure that if it lies to be between minus 1 sigma and plus 1 sigma, it is a very short range whereby we can tend to reject most of the defects that can happen, or we can try eliminating most of the defects that happen between the range. So this sigma we talk about as the standard deviation, and we talk more on the defective units. So we have specified a range in the plus minus sigmas, that is plus 1 sigma, plus 2 sigma, plus 3 sigma and minus 1 sigma, like that, and percentage of population within the range is also been given. Defective units per billion. So when it is, if you calculate the defect ratio when it is plus 1 sigma, then the defect ratio will be, the defect unit per billion will be very minimal. So it will be 1 in 317 crores. So when the defect has been very less, that means 1 in 317 crores, we tend to understand the quality of the product. So not only that, there are other quality control techniques, as we have already seen. There is another quality control technique which is called quality control charts. So a quality control chart is a graphical display of data that illustrates the results of a process over time. So it helps prevent defects and allows you to determine whether a process is in control or out of control. So as like deviation, standard deviation that we have followed in the sigma or normal distribution curve, here in the quality control chart we will tend to find out whether all the defects are in the process are in control or out of control. So this is, the center line is supposed to be the mean, and when there is a peak, this chart shows us a simple violation of a 7-run rule, where there are violations that has happened in those stars. So there seems to be a large violation that is happening at one specific time dimension. So by way of plotting this line chart, we will be able to mention where the quality has been slipped, or at what stages this quality requires more control in order to develop a better product. And during this phase of development, we may have to ensure Six Sigma concept, which is part of any organization, which is actually to be built in at any level of the organization. So when I say Six Sigma, it is something like almost anybody can assure on the product that they can build 99% defect free environment, and I am sure nobody can say that my product is 100% defect free. So at this juncture, between 99 and 100%, we can try, although we put in a lot of efforts to make the product from 99% to 100%, but then 100% is not achievable. So we may have to come out with standards such that this 99% can be taken up to the next level, say 99.99%. So that 0.99% needs to be closely looked at. So that is what is the indication that we get it from Six Sigma. So operating at a higher level of Six Sigma value, like Six Sigma, means the product's tolerance and control limits has a less variability. So if you look at trying to reduce the defects by use of sigma from the lower control limit and the upper control limit, trying to reduce from this level to this level, that is from 2.7 billion defects per billion to 2 defects per billion. So by reducing the number of defects, or by completing, it is not reducing, it is actually to eliminate the total number of defects that has been happening from the beginning or from the higher stage to the lower stage. So as I have already indicated during the quality control chart, there is a 7-run rule. The 7-run rule states that if 7 data points in a row are all below the mean, above the mean, or increasing or decreasing, then the process needs to be examined and for random, non-random problems. So if you take any specific problem, if there are 7 data points which are above and below the mean and try to increase to a larger volume and try to decrease to a larger volume, then we may have to considerably look at that particular non-random problem in detail. And finally, the last method that we may have to tell during the quality control is on the testing, where many IT professionals think of testing as a stage that comes near to the end of IT product development. As unlike we have seen during the phase of software development life cycle, we have studied testing as the last phase during the development or building stage. Like we have started with requirement specification and analysis, then we have gone down to design, we started building, and finally we have ended up in testing. So that is the keen thinking that every person used to have. So only after implementation of all the phases it comes to the testing component. So testing should be done during almost every phase. That is what we ensure. So when we look at testing in detail, we study more of the importance of testing. So as if you recall some of my initial sessions, more than 40% of the times the product is into testing. So that means the testing is given utmost importance and need not wait till the last stage that testing has to be given. So it should start from the beginning. So testing should be done during almost every phase of the IT product life cycle, starting from the requirements gathering and analysis. So at each and every phase there should be appropriate testing that should have happened. So testing tasks that we tend to provide in the software development life cycle model: initiate the project, feasibility, we tend to study the feasibility of the project, project planning, detailed requirements, product selection, system design, we tend to build, and we have a detailed architecture, build operating environment, physical database design, unit design, code, and unit design is parallelly being received for unit test. After having done the unit test, go for integration test, go for system test, go for user acceptance test, then try modifying or take all the strategies which have been considered for testing, then implement based on that, then it will be considered for post implementation. So all these ovals that I have highlighted, anything that has been projected as in oval, those are the testing tasks where we may have to give utmost importance to. So starting with feasibility, project planning, detailed requirements, system design, detailed architecture, physical database design, unit test, integration test, system test, user acceptance test, and post implementation. Almost we have highlighted all the phases of software development life cycle, but then almost all the phases in this 17 stage process requires testing as its independent task. So if you are able to do the complete of testing, we are ensuring the quality, and we are trying to control or overlook, or we are trying to assure that quality is being enforced at all the levels in the software development life cycle. By looking at the different types of testing, a unit test is done to test each individual component. So if you look at any specific individual component, or if you define it as a module or one simple process, then that needs to be tested. So often a program will be an individual component to ensure it is as defect free as possible. So integration testing occurs between unit and system testing to test the functionality grouped components. So any functionality that are trying to group, then that becomes an integration testing. And system testing tests the entire system as one entity. So I take the entire system as one specific entity, and when I try to test all the individual components putting together on integration, and finally I do a testing which is called system testing. And this will be in evaluation or in conjunction with the customer's requirements. So it will be user acceptance testing, is an independent test performed by the end user prior to accepting the delivered system. Improving on the IT project quality, Several suggestions have been given for improving the quality of IT projects, that include there should be a leadership which should concentrate on or who promotes quality at every level of development. So there should be people who will understand the cost of quality. And we may have to focus on organizational influences and workplace factors that affect quality, and we may have to confirm maturity models to improve quality. Let us look at a common scenario where we don't have a maturity model, we don't have a quality standard. Say for example, if my car is stuck in between, if I am traveling from office to home, if my car is stuck somewhere in between, do I have a person who is qualitative enough to call and attend the problem immediately, or do I have a doctor who is mentioned with appropriate quality standards? So these are some of the things that we may have to think in our brain. So this requires best practices that need to be involved. So specialists have come across. I don't need to check into a doctor who is not specialized in a particular field. I have to check into a doctor who are specialists in their fields. So I need to have some maturity model so that this model understands some of the best practices that has been conformance with the industry standards. So if I look at leadership, it is the most important that the top management needs to provide on the quality. In the absence of sincere manifestation of the interest at the top, little will happen below. So this has been defined by Juron. So a large percentage of quality problems are associated with the management, not on the technical issues. So mostly technical issues will be solved at the lower level of the organization, but then quality problems are associated purely with the management. This is one of the perception that every organization has got. Then comes the cost of quality. Cost of quality is on the cost of conformance or delivering products that meet requirements and fitness for use. This I have already mentioned. So cost of non-conformance or taking responsibility for failures or not meeting quality expectations. There can also be downtime caused by software defects, cost per hour of downtime caused by software defects. Say for example, if you look at businesses like automated teller machines, for a medium sized bank, cost per hour of downtime would cost this much. Onto a different application like telephone ticket sales, the cost per hour downtime, if it has been down or shut for an hour, it might cost a major amount. Airline reservation center. So there are different scenarios which explains you with all these business cases. 5 cost categories related to the quality. One is on the prevention cost. So the cost of planning and executing a project, so it is error free or with an acceptable error range, which becomes a prevention cost. There will be another cost which is called appraisal cost, which is something like the cost of evaluating processes and their outputs to ensure quality. And there is another cost which is called internal failure cost, which is nothing but a cost incurred to correct an identified defect before the customer receives the product. There are 2 other costs which is related to the quality, which is external failure cost, that is cost that relates to all errors not detected and corrected before delivery to the customer. So there are external failure costs, which is something like I have not identified it as an error and I have not detected it, but then it is corrected before delivery to the customer. So the last cost category is measurement and test equipment cost, which is something like capital cost of equipment used to perform prevention and appraisal activities. So by looking at all these 5 costs, starting from prevention, appraisal, internal failure, external failure, measurement and test equipment, it covers almost all categories of cost that is involved specific to an organization. So by ensuring, if you look at the previous definition that I have given, by ensuring quality on the product, the cost should get less, the cost should go down. So by looking at all these costs in detail, like prevention cost, internal failure cost, external failure cost, appraisal cost and things like that, when we look at all the costs in detail, there will be surely decrease in the cost parameter, by where we can ensure on the quality of the product. In short, in this particular session, I have looked at, on top of what Deming-Juran has defined, I have talked about Ishikawa's fishbone diagram, followed by Malcolm Baldrige's quality award. Further, we have looked at different quality control methods like Pareto analysis, which is 80-20 rule, statistical sampling, where we have defined the normal distribution and sigma standard deviation, quality control charts, and finally we have defined on the importance of testing. Not only that, we have looked at what is the importance of cost towards quality. How did we mention that as quality increases, cost will decrease? So, by looking at various factors like prevention cost, appraisal cost, internal failure cost, external failure cost, measurement and test equipment cost, if you look at keenly on all these categories of cost, surely if you try to eliminate different parameters associated with this cost, the cost might go down. Thank you.